which is binary operations. Now, the prerequisite knowledge to this topic is set theory and the binary numbers, which is modular. Good. Now, we have operations under the binary operations. What do you mean by operations? These are the code. We'll be using code as our operation. Instead of us having addition, subtraction, multiplication, division sign. In this case now, we'll be coding it with kind of image. Under these operations, we have asterisk. We also have circle as dot in. We have triangle, boss. We have another triangle, boss, turning upside down. Then we have a circle of star in. Now, don't forget that I said we are using operations. These are we call these operations. So in case we want to operate a certain digit or integers, we call it operation. Don't say theory asterisk. No. Theory operation. Whatever code you are using, whatever of the symbol you are using, whatever of the boss you are using, just call it operation. Now, I want to take you back to the memory lane of primary school when we have 3 plus 4, 4 plus 3. So this is actually what we are just trying to modify. We are advanced. We are in advanced level. Thank you. Now we also have symbols we use under these binary operations. As we all know, this is not a literature subject. So instead of us writing words, story, we use letters to decode our word. Now, symbols. Under N, we have natural numbers. We have R, which stand for real numbers. We have Q, which stand for rational numbers. We have Q prime, which stand for irrational numbers. We have Z, which stand for integers. Though we have category of Z, that which is integers. So forget that integers, these are positive or negative numbers. So you have Z that carry positive, we have Z that carry negative. But in nutshell, once you have Z, it's as simple as what? Integers. Then we have C, which is complex number. We have E, which is element. Don't forget, an element is the member of a set. Don't forget. As I said, we are borrowing terms from set theory. Now, when you have this, what is the main objective of this? In primary school then, let me take you back to the memory of primary learning. We have 3 plus 4, which is equal to 7. We can do it vice versa. 4 plus 3 will still give us the same answer, 7. But mind you, let us look at subtraction. Is it possible for us then, while we are in primary school? We say 4 minus 3 will give us 1. But if you are asked 3 minus 4, we just say it is impossible. No. In this case, it is possible. I want to show you that it is possible. It is minus 1. So we now want to look at the relationship between this positive and the negative numbers, or vice versa. We have properties of binary operations. These are how the operations, how they display. We have closure property. We have commutative property. We have associative property. We have distributive property. We have identity inverse, and identity element, and we have inverse element. But for this lesson, we are going to center on the 4 properties: closure property, commutative property. We are going to talk about inverse, and we're going to talk about identity elements. The others will be in advanced class. Thank you. Now, under closure property, which is the first, if you are given a non-empty set, that simply means that set is not empty. That's an element. What are the elements? Let us use a letter. S belongs to real numbers. How is the real numbers here? So if S and Y, under this closure property now, we want to choose particularly a positive integer. If S, Y belong or is an element of a positive integer. Now, for the fact that S and Y is a positive integer, if we are to show that this is a closure property, by the time we operate S and Y, it must be a positive integer. If it is not, if the result is not positive integer, then it is not closed. An example: S, Y is defined on Z. Don't forget, this Z here is positive integer, where S comma Y, where else operation Y. Simply, we'll be given the definition of our operation. Don't be rest assured that. Please don't shake. You'll be given the definition to the operation. The definition can be addition, it can be subtraction, multiplication, and division. Now, if you have S operation Y, which is equals to S plus Y, e.g., you want to use numbers now, you want to use positive integers. Since you said these elements are positive integers, 3 is a positive integer, 4 is a positive integer. Now, by the time I give the definition to this operation, which is plus, 3 plus 4 is equals to what? 7. If I also try it, 4 plus 2 is also what? 7. Now, good. Since our answer is a positive integer, definitely this operation is said to be closed. But look at the other way around. Minus 4 is not a positive integer. As you can see, it's a negative integer. So definitely minus 4 is not a positive integer. I get him now. So if I should operate this element, look at it. I'm operating minus 4 and 3. Minus 4 operation 3 is simply, I said that you'll be given the definition to your operation. In this example, the definition to this operation is positive. Now, if you have minus 4 plus 3, you are going to have minus 1. Minus 1 is not a positive integer. It is what? A negative integer. Thank you. So, in this case, this operation, it is said not to be closed. So, that means it is not closed. Now, we move also to the modular, another example, where you'll be using a modular to explain this closure property. Now, I want to show you how addition is closed under operation and how subtraction, is it closed or not? I will ask you to also research, also to try that on your own. But I want to show addition and multiplication. Addition and multiplication are always closed under operation, under this property. Now, if you have modulo 5, you all know that the set of modulo 5 is 0, 1, 2, 3, 4. Do you still remember the modulo 5? Yes. Operation, we want to operate this modulo 5. We have 0, 1, 2, 3, 4 on this column. We also have 0, 1, 2, 3, 4 on the row. Now, if I operate this, 0 plus 0, don't forget the modulo. What do you mean of modulo 5? That means our answers here must not be greater than 5. You rectify it to be under 5. Binary numbers. Don't forget, modulo 5. 0 plus 0. The definition of this operation is, look at the symbol, operation. But the definition here is addition. We are trying to look at addition. 0 plus 0 is 0. 0 plus 1, 1. 0 plus, and so on. 1 plus 4, it is 5. But I cannot write 5 because I'm choosing modulo 5. So my answer here will be 0. Look at that cell. The answer here will be 0. Since 5 divided by 5 is 1, remainder is 0. So we are writing the remainder down in the box, as you can see. Now, looking at this table of modulo 5, you observe that in each cell where you operate the modulo 5, all your entries here, there is no one that is outside of this set 0, 1, 2, 3, 4, as you can see. So in this case, the modulo 5, this operation is closed under this addition, modulo 5. Meanwhile, I think that we have something outside of these sets 0, 1, 2, 3, 4. We said the modulo not to be closed. So the operation is said not to be closed. But in this case now, our operation is closed. We also have multiplication. Look at the multiplication table here. We have 0 operation is 0, which simply means you multiply. 0 times 0 is 0. 0 times 1 is, I hope you understand that. Now, if I operate this, 2 times 3, you can see, 2 times 3 is 6. I won't write 6 because I'm treating modulo 5. So I'm going to write the remainder. The remainder here is what? 1. So now look at all my entries here. Look at all the cells here. You observe that there is no digit here that is outside of set of modulo 5, 0, 1, 2, 3, 4. So since there is no entry here that's outside of this set, we therefore say that the operation is said to be what? Is said to be closed. But under subtraction and division, the operation will not be closed. I want you to try that. Give a modulo 5 subtraction. 1 minus 2, it is minus 1. So in fact, that is very clear. Minus 1 is not in modulo 5. So definitely the subtraction is not closed. Also division. If you try for division, if you have 2 on the row and the column, if I divide 2 by 3, I'm going to have a decimal fraction. Is decimal fraction part of my set of modulo 5? No. So under closure property, addition and multiplication are always satisfied. So please take note of that. So that is explanation of closure property. Now let us move on. Let's move to the commutative property. What do you mean by commutative? What is source for the good is source for the gender. Now, if you are given a non-empty set such that this symbol simply means such that S operation Y belongs to real number. Now, what I'm trying to display here is that if I have S operation Y, I should be able to have Y operation S. That's my argument here. It is commutative. What is good? What is source for the good? Yeah, what is source for the goose? It's also source for the gander. Now, if I dance to the left, I should be able to have the result if I dance to the right. That's my argument here. If you are given a non-empty set, 3 operation 7, under let's give the definition to this operation. Symbol addition. 3 plus 7, that will give me 10. 7 plus 3, that will give me 10. Are you there? But let us try subtraction. 3 minus 7, that will give me minus 4. 7 minus 3 will give me 4. Is that commutative? No, because our answer is not the same. But under multiplication, 3 times 7. 3 times 7 is what? We have 3 times 7 to be 21. 7 times 3 is what? 21. So this is said to be closed because my left, if I take the left side, it's same as what? As the right side. So as you can see it here, if I take the subtraction and division, the property, the operation will not be closed. So under this property also, it is only addition and multiplication that is commutative. So if I have 3 minus 7 and I have 7 minus 3, if they are the same, no worry, you can go ahead. That means it is commutative. But in this case now that you see 7 minus 3 is not the same thing as 3 minus 7, the property is not to be commutative. So I believe under the, I want to take the to make you to understand better. Study these two properties, closure and commutative. They are always closed under addition and multiplication. As we all know, while you're in primary school, 3 plus 4 is the same as 4 plus 3. But if you are asked 3 minus 4, you say, no, it is impossible. Meanwhile, it is possible, minus 1. But because it is negative, now that I said it is impossible. In this case also, addition and subtraction is said not to be, addition is commutative, while subtraction is not commutative. So you'll be given an assignment to work under these two properties, which will intensify your knowledge under this topic. Thank you. The lesson 2, this is your assignment on the binary operation, the lesson 1. So please go through it. You have this. You'll be given the